Welcome to tonight's video on continuity. So a function, remember, is continuous if you can draw the entire function without lifting your pencil. So notice here, if I draw this function, when I get to this hole here, I have to pick it up. This is the dot, and then go to the other side. So that means that it is not continuous at x equals 2. So the interval of continuity is from negative infinity to 2, union 2 to infinity. Now, this is considered a removable discontinuity because there is a hole there with a dot somewhere else. If you look at this graph, the domain of this function is all real numbers, because notice the dot means that 2 is part of the domain. It's just not part of the parabola. As far as the limit as x goes to negative infinity, that would be negative infinity. The limit as x approaches positive infinity, remember infinity is here, negative infinity is there. Notice it's going down, so it's still negative infinity. The limit as x approaches 2, well, if you notice from the left and the right, it goes to the number 4. And then the function value, f of 2, is equal to 2. That's the dot right there. All right, the next one is an example of a non-removable jump discontinuity. Notice at x equals 2, it goes from one graph to the next. It jumps. So the domain here is all real numbers as well, because this is a dot here. The limit as x approaches infinity of g of x, well, here's infinity, and it looks like it's going towards 0. The limit as x approaches negative infinity is out here. It's going down to negative infinity. The limit as x approaches 2, well, if you look from the left it comes in and goes to 5. From the right, it goes towards negative 3. So therefore, the limit as x approaches 2 of g of x does not exist, because the limit from the left and the limit from the right are not the same. G of 2 is equal to negative 3. But this is an example of a non-removable jump discontinuity. The last type of discontinuity is when you have a vertical asymptote. That is an infinite discontinuity, non-removable. So the domain of h of x, well, the asymptote means that it's not in the domain, so it's negative infinity to 2, union 2 to infinity. The limit as x approaches infinity of h of x equals 1. Notice it goes towards 1 there. And negative infinity would also go to 1. The limit as x approaches 2, well, notice from the left it goes up towards infinity. And from the right, it goes down towards negative infinity. So therefore, the limit as x approaches 2 of the function does not exist. Now, here, if you notice, the reason that the limit did not exist is because the limit from the left does not equal the limit from the right. Right? Here, the reason the limit doesn't exist is because on the left and right, there's what's called unbounded behavior. That's what UBB stands for, because it goes either to infinity or negative infinity. So that means there is no limit. H of 2 is undefined. So a function is continuous at a certain x value if and only if three things occur. The limit as x approaches that number exists, the function value at that number exists, and the limit as x approaches that number of the function and the function value are the same. If not all of these are true, then you have a discontinuity at that point, and there's three types of discontinuity. Number one, non-removable discontinuities. A jump is when the limit as x approaches the number does not exist because the limit from the left does not equal the limit from the right. Infinite discontinuity, the limit as x approaches the number of f of x does not exist, and this is because of unbounded behavior. That's because it's going to be infinity or negative infinity on either side. A removable discontinuity, the limit as x approaches the number exists, but the limit as x approaches the number of the function does not equal the function value. All right. So a continuity table for problems, like for example this one, and so the headers here, I'm not going to rewrite them all, but they would go here. All right. So for problem number 4 here, the values it wants you to find the limit for, the first one is 0. So 0 is not a changing point of this piecewise function. So you don't need the limit from the left and the right. What you do need to do is just put it into the top. So f of 0 is 0. And then the function value is 0. So yes, it is the same. Is it continuous? Yes, which means there is no discontinuity. For 2 is a changing point, right? So from the left, when you put 2 in, you get 4. From the right, when you put 2 in, you get 3. So the limit does not exist. F of 2 is 4. They are not the same. It is not continuous. And this would be what's considered a non-removable jump discontinuity because the limit does not exist, because the limit from the left and the limit from the right are not the same. 3 is not a changing point because it's only for this part. So the limit as x approaches 3, if you do it from the left and the right here, from the left it's 2, and from the right it's also 2, so therefore it's 2. F of 2 is undefined, so therefore it's not the same, it's not continuous, and this would be a removable discontinuity because the limit exists, but the function value does not. So number 5, if you do the same table, the limit as x approaches c from the left, the limit as x approaches c from the right, the limit as x approaches c in general, f of c, and then you want to say, is f of c equal to the limit as x approaches c? Is f continuous at x equals c? And then, is there a type of discontinuity? Okay. So for the first one, -3, notice -3 is right here at the asymptote. So from the left, it goes to infinity. From the right, it's going down to negative infinity. That means the limit does not exist. The function value is undefined. No, no. And this would be an infinite discontinuity, non-removable infinite discontinuity, NRID. Then for 0, here's 0 right here. From the left, it goes to 0. From the right, it goes to 0. So therefore, the limit as x approaches 0 is 0. The function value is also 0. So it's yes, yes, and there is no discontinuity. So then for 2 is another asymptote. On both sides, it goes to infinity. But that means the limit does not exist, because even if they're both infinity, infinity is not a limit. That just means it goes on forever. The function value is undefined. It's no, no, and it's a non-removable infinite discontinuity. So 3 is over here. From the left, it goes to -1. From the right, it goes to -3. The limit does not exist. The function value is -3. It's no, no. And this is a jump. Because the reason the limit doesn't exist is because the left and right-hand limit are not the same. For 5, if you look here, 5 is right here. From the left and the right, it goes to -7. So it means the limit as x approaches 5 is -7, but the function value is all the way up here at 1. So it is not the same, it is not continuous, and this would be a removable. Because the limit exists, it's just that it's not the same as the function value. Alright, then at 7, from the left it goes to -3, from the right to -1. The limit doesn't exist. The function value is undefined because they're both open circles, and it's no, no, and this would be a jump. Alright, so the next question says, find the value of a such this is continuous on the interval from -infinity to infinity. Well, remember, if it's continuous, basically the limit from the left at 1, because remember, the only place you need to, for a piecewise function, c is the changing point, which is 3x to the third. So 3 times 1 to the third is 3. So the limit from the right also should equal 3. So that means the limit as x approaches 1 from the right of ax plus 5 is equal to 3. Right? So basically, when you put the 1 in for x and add 5, it has to equal 3. So a plus 5 equals 3. So a is going to equal -2. All right, and that's the number that will ensure that the limit from the left and right are the same, and it will also be the same as the function value. All right. This one here, well, first it would help to figure out where it's not continuous, and it would not be continuous at 5. So the interval where it's continuous is all real numbers except for 5, because 5 would make the bottom of the fraction equal 0. There's a discontinuity at x equals 5. And think about it. Well, f of 5 does not exist, right? It's undefined. So the function value doesn't exist. And also the limit as x approaches 5 from the left. Well, from the left is numbers like 4, 3. Think what happens when you put in those numbers Like, let's say you put in the number 4, you would get 1 over 1, which is 1. Or if you put in the number 3, you get 2 over 2, which is 1. But when you put in numbers from to the right that are bigger than 5, notice you get like 5 minus 6, which is negative 1, but the absolute value of negative 1 is 1 over negative 1, so you get negative 1. So that means the limit as x approaches 5 of this function does not exist, right? So the conditions that are not satisfied for discontinuity is basically all of them. F of 5 does not exist. The limit as x approaches 5 of the function does not exist. And that means that the limit as x approaches 5 of the function does not equal the function value. So all 3 conditions are not satisfied in this one. All right, that concludes our video for this evening. If you have any questions, please feel free to ask. Have a good evening.